Hello and welcome to another week of Relic. Okay, so on page 1, we're going to talk about possible outcomes. Okay, so Bernadette and Charles organized their outcomes in this table. They lost the counter and used a spinner labeled 1, 2, 3, and 4. Name the possible outcomes for this experiment. Okay, so for this, so possible outcomes. So red, so the possible outcomes are that red could equal 1, 2, 3, or 4. Okay? And then the yellow could also be 1, 2, 3, or 4. So what's happening right now, right, is that they're tossing a counter and then using a spinner. So it's like kind of looks like this, and then there's like this clock. There's like this hand, right? And then it would say, sorry, it's not working. Okay. Okay. Yeah. So there would be like 1, 2, 3, and 4, right? Okay. So it could. So say for example they have a color, right? They could spin the spinner, and it could be red 1, 2, 3, or 4. Same thing for yellow, since we're using the same spinner. Okay. So let's go to number 3. How many outcomes would there be if they use a spinner with 6 different numbers? Okay. So if we're trying to find possible outcomes, we can just multiply the number of the two factors. Okay, so since there are only 2 colors and since there are 6 different numbers, what we could do is we would multiply these two, and that would make it 12, right? And that would be there's 12 different numbers. Okay, wait, 12 different outcomes. Okay. So next we're going to page number 2, mixed test or mixed review and test prep. So 6 weeks, okay? So remember that 1 week we have 7 days, right? And then so 7 days. So since 7 days, so there's 6 weeks, right? So we multiply 7 times 6 because 1 week equals 7 days, which equals 42. Okay. Yeah. So for this one, I'll just tell you guys the measurements, the indications of time. Okay. So remember how we said a week is 7 days? Okay. A month is 4 weeks. Okay. 4 weeks. You technically don't need to know about that, but just for reference. And then there are 12 months in a year. Okay. So for this one, if you're trying to find how many years, so we would do 48 divided by 12. Okay. And the reason why we do this, why we do division for this one, for this one is because the measurement of the integration of time, right? The unit of time is actually smaller, or is actually bigger than is bigger than this. It's bigger than the other one. Okay. However, this indication of time, so weeks, is way longer than days, right? 1 week is way longer than 1 day, right? That's why we multiply. Okay, so when we're going from a bigger unit to a smaller unit, we would multiply. But if we're going from a smaller unit to a bigger unit, we would divide. Okay, so this would be 4 years. So 48 divided by 12 would be 4. How many sides does the hexagon have? So that would be 6. Okay, just remember that. This is simple parentheses. Okay, so this one's kind of hard. Actually, so we could do 14 minus 6. 14 minus c equals 6. So we could subtract 6 by both sides. So 14 minus 6 is 8. So 8 minus c equals 0. Now what we could do from here is we could add the c to both sides. So this will cancel out. So it would be c equals 8. Got it. Okay. Okay. So we're trying to find out whether the event is certain or impossible. Okay. So 6. Pulling a red pencil from a box of blue pencils. So there are no red pencils inside the box. Okay. Is it possible to pull out a red pencil? That's definitely impossible. Okay. Number 7. Pulling a quarter from a bag full of quarters. Can you pull a quarter from a bag full of quarters? That's definitely certain. Okay. You can definitely do that. Tossing a number less than 7 on a number cube, like 1 to 6. There is no 7, so definitely that's impossible. Okay. You can do the last one on your own. Okay. Okay. So predict what might have been: likely, possible but not certain, unlikely, and unexpected but not impossible, equally likely. So same probability for each item. Okay. Tossing a prime number on a cube, label 3, 5, 7, 9, 11, 13. Okay. So out of these 6 numbers, there's 5 prime numbers. Those prime numbers are 3, 5, 7, 11, and 13. Okay. 9 is the only one that's not a prime. How likely is it to toss a prime number? Is it likely, unlikely, or equally likely? It's definitely likely, right? Because there's more prime numbers, okay? So there's more chance of getting it. I'll do one more with you. So pulling a green marble from a bag that has 1 green, 6 yellow, and 5 red marbles. Will it be likely to find the green marble? That's definitely unlikely, right? Because there's less chances of getting it. Okay. Let's go to the last page. Okay. Which sum for 2 spins is more likely, 2 or 3? Or are they equally likely? Okay, so it seems like 1, 2, and 3, there's all equal chances of getting them, right? Therefore, it's probably equally likely to get all 3, or to get one of the 2. Okay, look at that point. Look at the bag of marbles for 3, 4. Which color are you most likely to pull from the bag? Why? Okay, so there's 1, 2, 3, 4, 5, 6 blue marbles. 1, 2, 3, 4, 5, 6 yellow marbles. 1, 2, 3, 4. Okay, that means most likely we would pull the yellow and the blue. Okay, and what color marble would you least likely be able to? That's probably the red, because there's less red, right? Okay, hope you guys learned a lot, and I'll see you guys next week.